right. Well, we are going to move into, let's see, I guess it's the third topic before your next lab assignment. And right after that will be your next midterm exam on the new Keynesian model. We're going to spend the next 2 weeks talking about this. So I'm going to go through this in kind of painstaking detail. I think I hinted at this last week, but this is, if I really think about this, it's probably conceptually some of the most challenging material of the semester. And so I want to work through it kind of slowly and deliberately so that you guys understand the model, how to interpret it, how to use it. I'm going to ask you questions on the labs and the exams that will really test your understanding about the mechanisms that are inside of the model. So we're going to go through several examples over the next 4 class periods on how to use this, okay? All right, so let's just kind of quickly recap what we talked about last week. In the last section in this course, we talked about how the Fed's primary macroeconomic objectives are encapsulated by this thing called the dual mandate. Now, who can remind me, what is the dual mandate? What 2 overall objectives does it represent? The Federal Reserve's dual mandate. Yeah, what's your name again? Jacob, go ahead. Price stability and full employment, right? So how does the Fed actually interpret price stability in practice? Jacob, do you remember what that means exactly? Exactly. The Fed wants to target the inflation rate of 2%, right? And inflation as measured specifically by the deflator for personal consumption expenditures, right? PCE inflation. How does the Fed interpret the full employment or maximum output side of the dual mandate? What does that mean in practice? You guys remember? What does full employment mean? So this is important to know as well. So not just the price stability side, but Levi? And what is that called? That's called potential output, right? So potential output is this kind of hypothetical level of output in the economy that would prevail if resources were being utilized fully and efficiently at a sustainable level, right? The Congressional Budget Office estimates what potential output is. And so the Fed tries to judge whether or not it's achieving this full employment maximum output or production side of the mandate by seeing how close GDP is to potential GDP. Good. Okay, now look, many times the 2 sides of the Fed's dual mandate coincide, okay? Stabilizing one can be done by stabilizing the other simultaneously, but sometimes the Fed runs into these situations where trying to satisfy both sides of its mandate is impossible, that the two objectives temporarily come into conflict with one another. That is to say, there is a trade-off between stabilizing inflation versus stabilizing the output gap, right? The deviation of output from potential. Now, a central bank like the Fed can try to compromise between these competing objectives by trying to implement policies that minimize a loss function. Remember, we spent some time talking about how that we can kind of mimic central bank preferences by deriving a quadratic loss function that kind of summarizes the overall cost to society or to the economy when inflation is not equal to target inflation and output is not equal to potential, right? The Fed can compromise between these competing goals by trying to identify policies that in some sense minimize that loss function, all right? Now, experience shows us that the best way for the Fed or any central bank to do that is to try to implement or follow a credible policy rule. Again, I'm recapping here. what does credibility mean, or why is that important? In what sense, what can, if a central bank's policy rule is credible rather than trying to implement discretion, right? What can that avoid? What is the advantage of a credible rule over something like a discretionary policy? There's one type of problem that credibility enables a central bank to avoid. You guys recall? Levi? The time and consistency problem. This problem that emerges when central banks have announced a policy today and then it becomes optimal to do something different in the future, right? If the Fed can achieve some level of credibility, it can avoid that time and consistency problem. Anybody? We talked about a specific policy rule that was developed over several decades ago in the early 90s that was named after a famous economist, right? And we studied his particular rule. What was that rule called? The Taylor rule, right? Now, the Taylor rule was useful for two reasons. One, it has been shown to actually describe actual Federal Reserve behavior pretty well over time. And also it's important because when you plug that type of rule into a forecasting model of the economy, it tends to perform well in the sense of generating low levels of loss. That is, it stabilizes inflation and the output gap reasonably well. Okay, now that's a full recap of what we did last week. What is missing from this conversation so far? Well, in determining which type of rule or policy setting is best in the sense of generating the lowest possible loss, kind of implicit in all of this analysis is an understanding about how different policy settings affect the, or are transmitted to, I should say, the outcome variables that we care about. So like inflation or the output gap in particular. All right. In other words, what's missing from this conversation is an explicit model of the economy that shows us precisely how changes in the central bank's policy setting, like an increase or a decrease in its interest rate, is actually going to affect the target variables that it cares about, like output and inflation. Okay. So macroeconomists sometimes refer to this as the transmission mechanism. That's just a fancy way of saying a particular model of the economy that shows explicitly how monetary policy adjustments affect these broader macroeconomic objectives. All right. That's what we want to try to accomplish over the next couple of weeks, is developing a model of the transmission mechanism that I think is useful and is one that central bankers around the world actually look at, okay? Now, the particular model that we're going to start developing today, to build on things that you may have seen in the past, I like to describe it as sort of an advanced version of this so-called ISLM model that you might have talked about in your intermediate macro class. Some of you may have covered its cousin called the ISMP model. Just by a quick show of hands, how many of you guys have seen that model before, or at least heard of it? The ISLM model or the ISMP model in your intermediate macro classes. Okay, so most of you. This model is kind of an advanced version of that particular model. Here's the basic outline of what we're going to do again over the next 4 days. The first part of that model we're going to focus on is the supply side of the model. And it's characterized by something called a new Keynesian Phillips curve. We're going to derive that new Keynesian Phillips curve today and look at some of its key properties. Okay, it is really the most important part of the actual model because it's going to characterize the types of trade-offs between inflation and the output gap that central banks are confronted with. The demand side of the new Keynesian model is governed by this thing called an ISMP equation, which is very similar to your ISLM type model in intermediate macro. So it's basically got two components. What you might recognize or hopefully recognize as an IS curve or an IS equation, coupled with a specific rule for monetary policy, or MP. What rule do you think we're going to use in developing this model? The Taylor rule, or at least a simplified version of the Taylor rule. All right, so this new Keynesian model features the Taylor rule as one of its key ingredients. That's probably very different than the type of model you talked about in intermediate macro. Okay, we are then, I won't get to this until the next class, but we will analyze the Phillips curve. Why do I have that? Okay, no, I don't have that twice. The new Keynesian Phillips curve and the ISMP curve together in equilibrium. So you can call that the ISMP Phillips curve PC model, or I just like to call it the new Keynesian model for short. So we'll discuss how you put those two pieces together to analyze different monetary policy situations in equilibrium. And we can do things like, how should the central bank respond to a demand shock? Or how should policy respond to a supply shock, or to changes in inflation expectations? Or what happens if there's a change in the inflation target? All of those kinds of questions can be analyzed within the context of the new Keynesian model. Really quickly, the last couple things I want to do. We want to understand the role of the Taylor principle for macro stability. This is different than the Taylor rule. Now, it turns out that the Taylor rule satisfies the Taylor principle, which is a principle named after the same economist. But we want to talk about exactly what that principle is and why it is vital for these classes of models to satisfy the Taylor principle. In particular, when the Taylor principle gets violated, as it probably has over certain parts of our history, you get wildly unstable inflation dynamics. Okay, one of the key reasons why macroeconomists think that we had kind of runaway inflation during the 1970s is that the monetary policy rule that was in place violated this thing called the Taylor principle. So we'll take a look at that. The last thing I want to add to this, and this is something that I added just recently, and that is examining the consequences of the zero lower bound. Okay, now look, in years past, we didn't really have to talk about these things, but I think it is abundantly clear since the financial crisis that anytime the US economy goes into a recession, it's very likely that the Fed's interest rate setting is going to bump up against what's called the zero lower bound on the nominal interest rate. That the Fed cannot actually lower the interest rate below zero in an effort to provide further stimulus to the economy. We didn't used to have to talk about this because in years past, there was enough room to lower the interest rate to fully fight recessions. But it has become clear that since the financial crisis, we've now had two episodes where the zero lower bound has we've come into contact with it. After the financial crisis, and then once again during this pandemic-related recession, interest rates are basically pegged at zero again. So we're going to need to figure out how to analyze this problem of the zero lower bound on interest rates in the context of this new Keynesian model. And hopefully what I'll be able to show you, and again, this won't be until next week, is how the zero lower bound creates real problems for a central banker in its efforts to try to stabilize the economy, okay? But the new Keynesian framework, I think, is useful because it can effectively accommodate a zero lower bound. Some of these other macro models that you might have learned of in past don't really make that accommodation very well. Okay, any questions so far? Now look, the stuff we're going to go through here is a bit complicated theoretically. So please, if any of this is confusing along the way, I want you to stop me and ask for clarification. All right, the new Keynesian or ISMP Phillips curve model is, I would argue, is a much more coherent, dynamic version of the kind of old school aggregate demand, aggregate supply model that you might have even been introduced to in principle. I'll tell you this, the large scale forecasting models that the Fed uses and that other central banks use around the world have hundreds of equations in them, okay? But if you strip out all of the extra features of those equations and really get down to the core set of relationships, you're going to find something that looks an awful lot like a new Keynesian model. It has a Phillips curve, it has an IS type curve, and it has different policy rules, okay? So the new Keynesian model is very much a model of the transmission mechanism that real world central bankers are looking at and using to inform their policy decision, okay? All right, now the supply, let me start with the supply side of the new Keynesian model first. It is characterized by something called a new Keynesian Phillips curve, okay? This is the focal point of the new Keynesian model. And like I said earlier, it generates these key policy trade-offs between the output gap and inflation, okay? Now let me stop here for a second. You guys know what the Phillips curve is. So we're going to talk about the new Keynesian Phillips curve. Obviously, there was a predecessor. I'll call it the old school Phillips curve. Did you guys ever study that in principles or in intermediate? What is the Phillips curve? Who can remind me? Jameson? Bingo. The old school Phillips curve is really nothing more than an empirical relationship or a statistical relationship between inflation and the rate of unemployment. Jameson in particular, it shows that it's basically a regression line that shows historically if unemployment rates rise, inflation can fall. Or that if unemployment rates fall, you're going to have rising inflation, right? Okay. There are, I would say this, that the traditional or old school Phillips curve is no longer taken very seriously among academics or policy professionals at central banks, okay? For a couple of reasons. One is, Jameson, it's purely a statistical relationship that has no theoretical underpinning. It's just somebody, Phillips himself took data and looked at this regression line between changes in the unemployment rate and changes in inflation. But there's no coherent economic story that underlies that relationship, okay? The new Keynesian Phillips curve has an actual economic story. And the other reason I think that's maybe even more problematic is that in recent decades, the old Phillips curve has not really fit the data very accurately. It's not been able to describe actual movements in inflation very well. It did a good job during the 50s and 60s and 70s, but less so in the past few decades. And so it's really not used anymore by practicing macroeconomists. Instead, economists have increasingly relied on something called the new Keynesian Phillips curve. It's both much more theoretically coherent, and it does a much better job of actually explaining real movements in the inflation rate over time. Okay, now the new Keynesian Phillips curve, again, is going to be the key source of the trade-offs in our model that the Fed or a central bank faces between the two sides of the dual mandate, if you will, okay? All right, our version of the new Keynesian Phillips curve, to provide some theoretical underpinnings for it, is based on a particular model of the economy called the sticky price model, okay? Don't know if you guys have heard of this particular model before. You may have covered it briefly in another macroeconomics class. So the sticky price model essentially has a couple of key features in it. It assumes that firms are populating an economy and that those firms have the expressed objective of trying to maximize their current and future profit. So whereas the old Phillips curve has no economic story, the new Keynesian Phillips curve assumes that firms are trying to maximize profits, okay? Now, there are a couple of key assumptions within this model that I need to briefly touch on here. One is that the firms that inhabit this particular model are monopolistically competitive, okay? They are not perfectly competitive, like you talked about in your macro principles class, okay? Under perfect competition, you guys recall what firms have to set their prices equal to. Simply, they simply set price equal to marginal cost. In a perfectly competitive world, firms are price takers. They have no pricing power. They simply set the price of their product, which, by the way, is identical to the product that other sellers are selling, right? Equal to their own marginal cost. Well, if we're going to talk about a sticky price model where firms are able to set their prices, then we have to actually depart from this perfect competition assumption. The most natural assumption is monopolistic competition. You guys talk about this in your intermediate microeconomics class, monopolistic competition. Here, firms have some price power over the prices of their goods. And why do they have that? Because in a monopolistic environment, the goods that sellers are providing are different from one seller to the next, right? You guys remember in principles, the classic example of a perfectly competitive market might be like the retail market for gasoline, right? Every gas station sells an identical product. A gallon of gas at one place is the same as it is at a different filling station. So all of those filling station owners have to charge the same price, which is just their marginal cost. In a monopolistically competitive world, there's product differentiation. That the goods that are being sold from one seller to the next are not perfect substitutes for one another, right? And because of that product differentiation, firms have some ability to set their prices. If we're going to talk about a sticky price model, we've got to assume that firms can actually set prices optimally. Okay, and I guess the key assumption of the model is this idea about sticky prices. Now, what does that mean? In the model, we're going to have some firms that have to set their price in advance of demand conditions materializing. All right, those are our so-called sticky price firms. The other firms in the economy will assume just have perfectly flexible prices. So the name of the model is actually a bit of a misnomer. It's a sticky price model, but there are also flexible price firms in the model and sticky price firms, both types. Okay, questions about the assumptions then. All right, so what the first thing we want to do here is derive the new Keynesian Phillips curve. See if we can develop a coherent microeconomic story for its foundation. Okay, now what does microeconomics tell us? You guys, hopefully you'll remember this. What is the optimal pricing rule for a monopolistically competitive firm? Remember, a perfectly competitive firm sets their own relative price, that is the price they charge relative to the overall price level, simply equal to their own marginal cost of production. What is true of a monopolistically competitive environment? Price is no longer equal to marginal cost, but it is equal to, you guys remember, it's a markup over their own marginal cost. So under monopolistic competition, firms would set their desired prices as, let's say, a 5 or a 10 or a 15% markup over their own individual costs, marginal costs of production, okay? That's basically the optimal kind of pricing decision for monopolistically competitive firms. Let me write an equation down that illustrates that basic idea, okay? Now let me just develop a little notation here so you guys aren't confused by this. The left-hand side of this equation tells us what the firm's relative price is. Relative price, okay? Little p is the firm's actual desired price. Capital P is the aggregate or the overall price level in the economy. So just to be clear, The convention in these types of models is to write the variables in terms of natural logarithms so that the variables can be represented as percentages over time, okay? So these variables over here are logs, natural logarithms of the firm's desired price, right? When you think of a relative price, it's the firm's price divided by the overall price, right? But if you write that in natural logarithms, what happens? The log rule of division means you can separate it, and it's the log of one minus the log of the other, right? So this would be like the log of the firm's price minus the log of the aggregate or overall price. Similarly, the right-hand side is the output gap. It's the percentage deviation between actual output, Y, and potential output, YP, where again, these are written in logarithms, natural logarithms. A is just some constant bigger than 0, okay? Okay, now, let me interpret this equation here real quick. What this equation says is that the firm's desired relative price, relative to the overall price level, is some constant fraction or constant times the output gap, okay? Now, what is the theory underlining that? Think about this for a second. As actual output starts to exceed potential output, demand conditions are strengthening in the economy. What's going to happen to firms' marginal costs of production then? Marginal costs are going to rise, and firms are therefore going to want to increase their relative price in response to the higher marginal costs. So this equation is fully consistent with this idea that a monopolistically competitive firm wants to set its relative price as some constant markup over its own individual marginal costs of production, where marginal cost is related to the output gap in the economy. As the output gap goes up, marginal cost goes up. As production falls below potential, firms' marginal costs fall as well. Okay. Everybody okay with that so far? There are two types of firms in this economy: flexible price firms and sticky price firms, okay? I'm going to call this S parameter, this is a fraction, so just between 0 and 1. This is the fraction of firms that have sticky prices in our economy. So 1 minus S is just the fraction that have flexible prices, right? If S is 1/2, what are we saying? 50% of firms are sticky price firms and 50% are flexible price firms. Easy enough. Okay, now, if Jameson, let's say that you are the manager of a flexible price firm, how are you going to want to set your desired price? Easy. If you have fully flexible prices, you want to follow this optimal price setting rule. You're going to set your own individual price equal to the overall price plus this fraction A or constant A times the output gap. You're setting your own relative price as a markup over marginal cost, okay? That's how the flexible price firms behave. How do the sticky price firms behave? They have sticky prices in the sense that, Levi, let's say that you're a manager of a sticky price firm. You have to determine what your desired price is before you actually know what the overall price level or the level of actual demand is in the economy. In other words, you have to form your desired price based on a forecast of what you think the actual price level and the actual level of output is going to be, right? So you set your desired price equal to expected price plus A times the expected level of output minus potential output. Now, in writing this, Levi, we've made an assumption here that firms know the level of potential output. They all know how much output the economy would produce if all resources were being fully utilized. So we don't actually need to make a forecast of that. So we know what potential output is, all right? Now, we're going to assume here, to make the arithmetic as easy as possible, that Levi, your sticky price firm is going to form expectations of actual output in the following way. You're just going to assume that expected output will equal potential. All right, one way you can rationalize this is by thinking that firms are going to assume that the central bank tries to bring actual output in line with potential over time. So your forecast of output is going to be equal to potential output. Okay, now what's the implication of that? If expected output is equal to potential output, then Levi, your desired price is simply going to be your expectation of what the overall or aggregate price level is going to be. Okay, so this is the way that flexible prices behave. This is the way that sticky price firms behave. Make sense? All right. What if I want to find what the overall price level then is going to be in equilibrium? How do I do that? Well, if S% of the firms are sticky price firms and 1 minus S are flexible price firms, then the aggregate or overall price level is just going to be equal to S times the price that sticky price firms charge, which is PE, plus 1 minus S times the price that these flexible price firms charge, which is P plus A times the output gap. Okay? I can solve this equation for the overall price level then. It's just a simple little bit of algebra. Bring this 1 minus S times P to the left-hand side, and you get SP is equal to S expected price plus 1 minus SA times the output gap. I can then divide both sides of the equation by S, and what do we get? In equilibrium, the aggregate or overall price level is going to be equal to the expected price level plus 1 minus S times A divided by S times the output gap. Okay, let's interpret this result. I want to stop doing the math for a minute and make sure you guys understand the economics, okay? First off, what happens, let's say, I want you guys to tell me, what happens to the overall price level if the expected price level goes up by, let's say, 1%? If the expected price level goes up by 1%, the overall price level goes up by 1%. Now, why does that happen? If the expected price level rises, Levi, you're my sticky price firm here. You're going to raise your desired price, right? That's going to put upward pressure on the overall price level. Jameson, you're my flexible price firm. If the actual price level starts to rise, you're going to increase your own desired price because you can respond immediately to that development. So that means that the overall price level is going to respond 1-to-1 to a change in expected prices. Okay? Second point I want to make. What happens when demand conditions rise in a way that makes actual output bigger than potential output? When that happens, real marginal cost is going to go higher, like we talked about earlier, right? So when real marginal cost rises, who's going to change their price immediately? The flexible price firm or the sticky price firm? Only the flexible price firm, right? The sticky price firms cannot respond instantly to changes in marginal cost. And so when marginal cost goes up, because the output gap goes up, that also puts upward pressure on the overall price level. But notice here that it doesn't affect it 1-to-1, right? How much does the overall price level go up by? Whatever this kind of term is here, 1 minus SA over S. That number gets bigger if 1 minus S is larger, meaning that there are more flexible price firms in the economy. But Levi, what happens if there are more sticky price firms like yourself in the economy? S gets bigger, and the effect of a change on the output gap on the price level gets smaller. Why? Because more firms in the economy have sticky prices, and can't respond to the change in the output gap or marginal cost, right? The larger is S, the smaller is the impact, or the larger is 1 minus S, the bigger is the impact of the output gap on the overall price level. I want to be clear about that. The reason why this second term affects the price level is because of the existence of these flexible price firms that can respond quickly to changes in marginal cost and the output gap. The reason why expected inflation is in this equation, however, is because of the existence of these sticky price firms that have to set their prices in advance as just a function of the expected price level. Okay? Now, how do we get a Phillips curve out of this? Some of you guys might recognize this as like an aggregate supply equation, right? You guys remember from intermediate macro, maybe you talked about aggregate supply. How did you graph it? You had the price, the overall price level on the vertical axis and the economy's level of output on the horizontal axis. Well, that's what this equation is for given levels of expected prices and potential output. But what I want to do is derive an actual Phillips curve, which shows how the inflation rate is related to some of this right-hand side stuff, okay? The first thing I'm going to do is to make the equation more realistic, I'm going to insert what's called a supply shock on the right-hand side. This recognizes the fact that there are things that affect the price level in the economy that might not come or be directly related to firms' marginal costs, all right? So oil shocks or other types of supply disturbances that might cause the aggregate price level to move around. I want to accommodate those. So let's put in a supply shock. That's what epsilon is. Okay, how do we transform this thing into a Phillips curve? Well, the key step is to subtract the value of the price level in the previous period from both sides of the equation. Remember what the inflation rate is. It's the percentage change in the aggregate price level. So if we subtract the log of the price level from the previous period, then what do we have? We have on the left-hand side now, inflation is equal to expected price minus last period's price would be the expected rate of inflation, plus 1 minus SA over S times the output gap plus this supply shock. Okay? Now, I'm lazy, okay, relatively speaking. So I'm going to simplify this a little bit. This term here, 1 minus S times A over S, I'm going to combine this into a single parameter called kappa, okay? That's going to be essentially the slope coefficient in my Phillips curve. I'm also going to recognize that this Y minus YP term is precisely the output gap, okay, which was that little y tilde that we developed in the last section of the course, okay? This gives me then a derivation of the new Keynesian Phillips curve, which says that actual or current inflation is equal to expected inflation plus kappa times the output gap plus a supply shock. Now, I don't think I put this in your slides because I just did it today. This is an example of what the old school Phillips curve looks like. Essentially, that current inflation is equal to some previous value of inflation minus some constant times the economy's unemployment rate. All right, that's the old Phillips curve that we're not going to use in our model. But I wrote it on these slides because I want you guys to see the real differences between the traditional Phillips curve and the new Keynesian Phillips curve. There are two extremely important differences that I want you to know about, okay? Number one, what measure of inflation on the right-hand side of the equation is driving current inflation? In the new Keynesian Phillips curve, what matters for current inflation is expected inflation, not lagged inflation. The new Keynesian Phillips curve is very much forward-looking. prices depend on what firms expect prices to be in the future. The old Phillips curve has inflation depending on what inflation was in a previous period, simply because incorporating that variable helped the regression line fit the data better, okay? The other key difference between the old Phillips curve and the new is the other variable that's driving inflation cyclically. In the old Phillips curve, it's changes in the unemployment rate. That's not microeconomically coherent, right? The variable that matters in the new Keynesian Phillips curve is the output gap, which is theoretically related to firms' marginal cost of production. So this equation here is much more consistent with an underlying story of firms kind of behaving optimally, okay? This one here doesn't have any kind of microeconomic story that makes any sense at all. Okay, y'all have any questions about that so far? So let me again emphasize the three ingredients of the new Keynesian Phillips curve, okay? In this Phillips curve, what is driving actual inflation over time are three things. One would be inflation expectations, okay? When these firms in our economy that have sticky prices suddenly think that prices are going to be higher in the future, they start to increase their own prices, which puts upward pressure on the actual price level and therefore inflation. So again, the reason why expected inflation is a key right-hand side variable is because of the existence of these sticky price firms in the economy. The other is the output gap, right? And again, anytime there's excess demand for goods and services, which tends to push up output above potential output, that's going to elevate firms' marginal costs. Now, not every firm in the economy can actually respond to that development, though. Even though all firms are now facing these elevated costs, only the firms like Jameson's that have flexible prices can actually respond to that by raising their desired prices. But that has the effect of putting upward pressure on the overall price level and therefore inflation, with a constant of kappa attached to it, which depends on the size of the sticky price portion of the economy relative to the flexible price portion of the economy. That is that parameter S. And the third ingredient in the new Keynesian Phillips curve is this temporary supply shock. There are going to be occasions where there will be supply disruptions, oil supply disruptions, agricultural disruptions, which may cause the price level to increase without directly affecting things like marginal cost, okay? We need to be able to account for those things in a model, and so we're going to include them in this kind of elementary way, I should say, by just adding a random shock to the Phillips curve, okay? All right, how is that so far? That's the best I could do as far as explaining, well, not the best I could do, but I gave it the old college try. Explaining the theoretical underpinnings of the new Keynesian Phillips curve, okay? Now look, I'm not gonna ask you all to derive the Phillips curve on an exam, okay? I want you to be familiar with it. And in the context of a problem, I might even also present the Phillips curve to you, so you don't need to memorize the variables. Most of the time, dare I say all of the time, I'm going to ask you to work with a graphical representation of the Phillips curve. And that's, by the way, one of the reasons why I want to focus on this new Keynesian model, is because even though it can be derived from this nice story about how firms behave, we can depict the key relationships graphically in a way that might be a bit more intuitive for undergraduate students, okay? So let me spend a few minutes doing that. What if I ask you guys to graph the Phillips curve for me, where we graph inflation on the vertical axis, and then the output gap as our variable on the horizontal axis, okay? So again, here is our equation for the Phillips curve. All right. Now, what does this actual line show? Let's be clear about this. What does this particular line show? It shows every possible combination of the output gap and inflation that satisfies this equation, that is the Phillips curve. Okay? Now you will notice that there are 4 variables in the Phillips curve, right? Inflation, output gap, expected inflation, and the supply shock. The graph, however, is a 2-dimensional object, right? We're graphing the Phillips curve in output gap inflation space, right? So what does that mean we are assuming then about these other 2 variables, expected inflation and the supply shock? We're holding those fixed for the time being, right? So just like a demand curve shows the relationship between price and quantity demanded, holding fixed income, holding fixed the prices of related goods, in the new Keynesian Phillips curve, we're graphing the relationship between the output gap and inflation, holding fixed expected inflation and the supply shock. That is why I've labeled the Phillips curve here with this parenthetical argument, which shows that expected inflation is equal to, let's say, pi 1, and there are currently no supply shocks. So epsilon is 0. When you guys draw it on your lab and on your exam, you need to do this. I need to be sure that you understand that the Phillips curve is for given values of expected inflation and the supply shock. In the next slide, we're going to talk about what happens when expected inflation changes or when there is a supply shock. You might already imagine that the position of the entire Phillips curve is going to start to shift, okay? Just like a change in income shifts the position of a demand curve in micro principles. Okay, let's talk about this a little bit more here. So this is a graph of the Phillips curve. What if I were to tell you that there's currently 0 output gap, so output is equal to potential, and there are currently no supply shocks, and that expected inflation was exactly equal to pi 1, okay? So what would be the current value of inflation then, according to this graph? Well, you go to the output gap of 0, there's no supply shocks, and if expected inflation is pi 1, then what does the Phillips curve tell us is going to be the value of pi? Pi 1 plus kappa times 0 plus a supply shock of 0. So the value of inflation would be exactly equal to pi 1, right? This basically just identifies kind of the neutral point on that Phillips curve, right? Now, what do you see happening here? As the output gap goes up, what happens to inflation? Inflation rises, right? And what is the relationship between those two? That is, what is the slope of the Phillips curve? It's given by this kappa parameter, okay? That is key because that parameter, the slope of the Phillips curve, basically kind of summarizes the trade-offs that a central bank is going to face when it tries to stabilize inflation or the output gap, okay? Think about this. If the output gap were 0 and the Fed wanted to lower inflation below pi 1, let's say closer to its target level of inflation, what the Phillips curve shows us is that the Fed or a central bank is going to have to implement a negative output gap. How far the output gap falls for a given change in inflation is measured by the slope of the Phillips curve, right? So kappa kind of encapsulates that trade-off between inflation and output gap stability that a central banker is going to face, all right? Now, let me ask you this follow-up question here. What happens if prices suddenly become stickier in this economy? All right. So more of you flexible price firms now find yourself in a situation where you have sticky prices like Levi. What do you think happens to the shape of the Phillips curve in that case? Derek? Okay, go ahead. Why? Kappa is 1 minus S times A over S. If S gets bigger, and therefore 1 minus S shrinks, that kappa parameter gets smaller. It gets closer to 0, and the entire Phillips curve flattens out. Okay? Hopefully you guys see when that's the case, there's going to be a more severe trade-off that the central bank faces in trying to stabilize inflation and the output gap. Now, Derek, in order to lower inflation by, let's say, 1 percentage point, what does the central bank have to do? Generate an even bigger negative output gap. So the stickier prices become, the more firms that have sticky prices in the economy, the harder it's going to be for a central bank to try to stabilize inflation relative to the output gap and vice versa. As prices get more flexible, or as more firms have flexible prices, the Phillips curve steepens, and that trade-off is less severe. You can generate a big reduction in inflation with just a minor output gap in that case. Very good. Okay, what happens to the Phillips curve if there is, let's say, an adverse supply shock? So how do we model that, first of all? How do we think about this? An adverse supply shock is one that puts upward pressure on prices and inflation, all else equal. So the way we would model or think about something like an adverse supply shock, like an oil supply disruption, or a war, or a pandemic, would be a positive value of epsilon, okay? What happens if there is a positive value of epsilon to the entire Phillips curve, you think? It's going to shift up, right? If epsilon is now a positive number, the whole relationship between the output gap and inflation is going to shift up. Now, again, be careful here. You'll notice that if expected inflation is still equal to pi 1, then what is actual inflation going to be equal to? Pi 1 plus kappa times 0% output gap plus whatever the value of the supply shock is. So actual inflation is pi 1 plus epsilon. In other words, the whole Phillips curve shifts up by the size of the supply shock. What happens to the Phillips curve, let's say, if there is a sudden reduction in inflation expectations? Now firms revise their forecasts of the future, and they think the price level is going to be lower. How do you think that affects the Phillips curve? It's going to shift it down, right? So again, we'll go back to the case where there's no supply shock. If the expected inflation declines to, let's say, pi 2, we'll say that's less than pi 1, then actual inflation is pi 2 plus kappa times 0 plus 0, giving us a level of actual inflation equal to pi 2. So the whole Phillips curve would shift down vertically by the size of the drop in expected inflation, right? So be mindful of that. Kappa tells us about the slope of the Phillips curve. And that slope is really a function of the number of sticky price versus flexible price firms in the economy. The position of the Phillips curve, however, can move around if there are changes in expected inflation or the supply shock. Later on, I'm going to ask you guys to analyze the equilibrium response to changes in things like expected inflation and supply shock. But to do that, you of course have to have an ISMP equation in the model as well. Okay, questions so far? So that is my presentation then of the supply side of the new Keynesian model. Let me move into the demand side now, and I probably won't quite be able to finish it all, but I will be able to get it finished in the next class. Okay, the demand side of the new Keynesian model is characterized by something called an ISMP equation. Now, where does the IS part come from? Well, hopefully you guys remember kind of the textbook IS equation from your intermediate macro class, okay? This is basically what it looks like, all right? it shows us or argues that the IS relationship is a downward sloping relationship between the economy's level of real output and the interest rate that would emerge under a fixed price level. All right, now you guys probably went through a derivation of the IS curve in your intermediate macro class. But what I'll tell you is that there are two kinds of problems with this standard textbook treatment of the IS curve. Now, I don't want to trash what you did in intermediate macro or unlearn what you learned in intermediate macro, but let me kind of just add on to this. All right. The first problem with the traditional IS setup is that it doesn't really make any distinction between nominal and real interest rates. Now, why is that? The price level in the economy is assumed to be fixed in that model. If the price level is fixed, what's the inflation rate equal to? 0, which means the nominal interest rate is always equal to the real interest rate. We don't want to live in that world, right? We want to be talking about changes in inflation over time. So we need a distinction between nominal and real interest rate. We need to depart from the assumption of fully rigid fixed prices. Okay, so the traditional IS equation is not going to suffice for us. Okay, and the second thing is there are really no clear microeconomic foundations to this IS curve either. I mean, this is a quick recap of that story. Maybe you guys remember this. This will help kind of jog your memory. The IS curve is built up from this story called the Keynesian cross, where you have in equilibrium, planned expenditures are equal to actual expenditures. And what is it that adjusts in equilibrium to balance those things? Or firms' inventory, right? And interest rates will move up or down, and inventories will adjust until planned and actual expenditures equal one another, right? There was the aggregate expenditures line and like a 45-degree line, and the intersection was this so-called Keynesian cross, right? I don't think that's a very useful story of the macro economy. So what I'm going to do is I'm going to basically, I'm not going to formally derive this, but I'm going to just briefly discuss here instead why actual output should probably be related to the real interest rate in equilibrium rather than the nominal interest rate. All right. And instead of providing like a derivation that runs through a bunch of equations, let me just give a more coherent microeconomic rationale for why actual output should probably be related to the real interest rate in a proper IS type equation. Number one, think about this. A higher real interest rate should lower current consumption to the extent that people are going to have an incentive to save more in order to take advantage of the higher real interest rate. As long as that substitution effect dominates people's income effects, then a higher real interest rate will cause people to substitute away from current consumption in favor of future consumption, that is current savings, right? You guys may have studied that in terms of what's called intertemporal substitution. That's a key channel in these dynamic macro models. Higher interest rates lead to lower consumption, and of course, lower consumption reduces GDP or real output. What's another component of GDP is investment, right? What happens to national investment if real interest rates are higher? Well, they go down, right? And why is that? Because as real interest rates rise, firms that have to borrow to make investments are going to have higher borrowing costs, so they reduce their investment expenditure. But even those firms that don't have to borrow, at higher interest rates, they would rather be savers. So the opportunity cost of investment goes down, goes up when real interest rates rise. So what we tend to see in a microeconomic story of these things is that as real interest rates rise, both consumption and investment tend to decline. One other one that I'll throw at you, since we've talked about an open economy setup in this class, is that you might recall that a higher domestic real interest rate makes our domestic assets more attractive relative to foreign assets. When that's the case, foreign investors want to buy our assets. They have to buy our assets with US dollars. That raises the demand for US currency in foreign exchange markets. And what does that do to our exchange rate? It raises it. Now, what happens when our exchange rate goes up? Quick review. That makes US goods more expensive relative to foreign goods. So our exports start to decline and our imports start to rise. So what happens to US net exports? They go down. So you have consumption, investment, and net exports all tending to decline when real interest rates go up, or alternatively, if real interest rates go down, those three variables would tend to increase. I think that's a better story about why there's a negative relationship between the level of output and the real interest rate. Now, to summarize this in terms of an equation that we can use, we're going to put these ideas into what we call an IS curve or IS equation in our new Keynesian model. And this is what it looks like. Actual output is simply going to be equal to potential output minus the difference between the real interest rate, that's the nominal rate minus inflation, and R star. What is R star? That's the equilibrium real interest rate. That was one of the components of the Taylor rule, right? Plus U. U is going to be a demand shock, all right? There's 3 points I want to make about this very simple IS equation. You will notice that when actual output is equal to potential output, and when there are no demand shocks, so U is 0, then what do we have? Actual and potential output are the same, and you have that the real interest rate out of this equation is going to be exactly equal to R star. So the equilibrium real interest rate is the real interest rate that would prevail if output was exactly equal to potential output, which is consistent with what we talked about in the last class with regard to the Taylor rule. Same basic idea. So R star is that natural or equilibrium real interest rate, where output is going to be equal to potential output. Okay? Second point I want to raise about this, and this one's probably the most important. If the real interest rate, that is I minus pi, falls below R star, then what happens to actual output? If the real interest rate falls below R star, meaning what? That the stance of monetary policy is easy or accommodative, then what happens to actual output as I minus pi, as the real interest rate falls compared to R star? It enters the equation with a negative sign. So a lower real interest rate is going to do what? Is going to boost actual output above potential. Hopefully this makes sense to you guys. An expansionary monetary policy is one that drives the interest rate lower and so makes the real interest rate lower than the equilibrium real interest rate. It's an expansionary monetary policy because it raises or stimulates economic activity above potential output. What is a contractionary monetary policy? It's one that raises interest rates above the equilibrium real rate. When the real rate is above R star, what happens to actual output? It's going to fall below potential, right? Again, that's why we have this negative relationship between the real interest rate and output in the IS equation. It captures this idea that expansionary monetary policy raises output above potential, whereas contractionary policy lowers output below potential. And then the third ingredient of the IS equation is just going to be this demand shock. There are lots of factors in our economy, things like fiscal policy, changes in consumer sentiment, sudden changes in asset prices that might cause actual output to depart from potential output. If we want to account for those kinds of extra features, we can simply do that by adding a demand shock into the model. Okay, you guys have any questions about that? So to fully characterize the demand side of this model, we have to take our IS equation and we have to marry it to the monetary policy rule, okay? That's what I want to try to accomplish for the first, let's say, 30 minutes or so of the next class, so that we can fully derive the demand side of this model. And then we can take a look at the Phillips curve and the ISMP curve together and talk about equilibrium, all right? I don't have enough time to fully develop the monetary policy rule before 6:15, so let me just stop there. I think we've done enough for today, and we'll call it a day, and then we'll pick up on this stuff in the next class. So the goal for by the end of class on Wednesday is to have the full model derived and then work through at least one or two examples of what happens in equilibrium, okay? Next week, we will talk about the Taylor principle and how we can accommodate the model to feature the zero lower bound on interest rates. So you can see here, it's going to take us several days to get through all of this stuff. Okay, I will see you guys on Wednesday.